What is time? It's a question that sounds simple, but the more we think about it, the harder it becomes to answer. Every day we live by time. We wake up when the alarm rings, we go to work or school on schedule, and we count the years as we grow older. Time is always moving forward, and we shape our entire lives around it. Yet, if someone asked us to explain what time really is, most of us would struggle. Is time just the ticking of a clock? Is it something physical or only an idea in our minds? Scientists and philosophers have asked these questions for centuries, and even today, there's no single answer. What we do know is that time is not just important for us. It is one of the most mysterious forces in the entire universe. For most of human history, people thought of time as a way to measure change. When the sun rose and set, it showed the passing of a day. When the seasons shifted from summer to winter, it showed the passing of a year. Ancient civilizations built sundials, water clocks, and calendars to keep track of time. These tools helped them plant crops, celebrate festivals, and organize their lives. But time is more than just day and night. As societies advanced, people wanted more accuracy. The invention of mechanical clocks in the Middle Ages allowed us to divide time into hours and minutes. Later, pendulum clocks and pocket watches made it possible to measure time with even greater precision. Today, the most accurate clocks in the world are atomic clocks. These clocks don't rely on gears or sunlight. They measure time using the vibrations of atoms. They are so precise that they would not lose even a second in millions of years. Measuring time has always been about more than just knowing the hour. It's how humans learned to coordinate, build, and explore. Without reliable time, we could not have railways, airplanes, or global communication. Even technologies like GPS rely on atomic clocks to work. So when we talk about time as a measurement, we are really talking about one of the most important foundations of human progress. But measurement is only the beginning. Science shows us that time is not just something we measure. It is something much deeper, something woven into the fabric of the universe itself. When we look at time through the eyes of science, it becomes far more mysterious than just clocks and calendars. In physics, time is not a separate thing ticking away in the background. Instead, it is considered a dimension, just like length, width, and height. Together with space, it forms what scientists call spacetime. Albert Einstein completely changed how we understand time with his theory of relativity. Before Einstein, people believed time was absolute, the same for everyone, everywhere. But Einstein showed that time is relative. It can actually change depending on how fast you're moving or how strong the pull of gravity is around you. This idea is called time dilation. Imagine two twins. One stays on Earth, while the other travels near the speed of light in a spaceship. When the traveling twin returns, they will have aged less than the twin who stayed on Earth. For the traveler, time passed more slowly. This may sound like science fiction, but experiments with high-speed airplanes, satellites, and atomic clocks have confirmed that it's real. Gravity can also bend time. Near a massive object, like a planet or a black hole, time runs slower compared to places with weaker gravity. That means if you stood close to a black hole, even for a short while, years might pass for people far away, while only minutes pass for you. So, in physics, time is not fixed and unchanging. It is flexible, connected to motion and gravity, and it behaves in ways that our everyday experience cannot easily show us. This reveals that time is not just something we count. It is part of the very structure of the universe. To really understand time, we have to see how it is connected to space. Scientists discovered that space and time are not separate things. They are woven together into one fabric called spacetime. This idea might sound strange, but it helps explain some of the biggest mysteries of the universe. Imagine spacetime as a giant invisible sheet stretched across the universe. Planets, stars, and galaxies all sit on this sheet, and their weight bends and curves it. This bending is what we experience as gravity. When you drop a ball and it falls to the ground, it's not just being pulled, it's actually following the curve of space-time around Earth. But here's the amazing part. When space-time bends, time itself bends too. The stronger the gravity, the slower time moves. Near something as powerful as a black hole, time becomes so distorted that what feels like minutes for you could be years for someone far away. Movies and stories often show this as science fiction, but in reality, it is based on solid science. Spacetime also explains why the universe is expanding. Ever since the Big Bang, space and time have been stretching together. This means that the universe doesn't just exist in time, it is built with time. Without space-time, our idea of past, present, and future wouldn't even exist. So when we talk about space-time, we're not just describing a scientific theory, we are describing the stage on which the entire universe plays out. Every star, every planet, and every moment in our lives is written into this vast fabric. And because space-time can bend and stretch, time itself is not fixed, but part of a living, dynamic universe. One of the deepest mysteries about time is its direction. Time always seems to move forward. We remember the past, but not the future. We grow older, but never younger. A broken glass does not put itself back together. This one-way flow is called the arrow of time. But why does time move forward at all? Physics gives us a clue through a concept called entropy. Entropy is a measure of disorder. In simple words, it means things naturally move from order to disorder. Imagine a clean room. Over time, it gets messy unless you put in energy to clean it. Or think of an ice cube left outside. It melts into water, but that water never just turns back into an ice cube on its own. This increase in disorder creates the arrow of time. The universe started in a state of low entropy, very ordered, at the Big Bang. Since then, entropy has been increasing, and that's why time feels like it's moving in one direction. The past is the ordered beginning, and the future is the messy, more disordered state that is still unfolding. The arrow of time is also why we have memory. Our brains can record events that happened, but they cannot record events that have not yet occurred. The flow of time is built into the very way we live and think. What makes this so mysterious is that many of the basic laws of physics don't care about direction. Equations in physics usually work the same forward or backward. But when we look at the universe as a whole, time only flows one way. Scientists are still trying to fully understand why. So, the arrow of time is more than just a feeling. It is a physical property of the universe, driven by entropy, shaping everything from the smallest particles to the fate of galaxies. When we look at time on the scale of the universe, it becomes even more fascinating. The story of time, as we know, it begins with the Big Bang, about 13.8 billion years ago. Many scientists believe that not only space, but time itself began at that moment. Before the Big Bang, asking what happened before may not even make sense because without time, the idea of before doesn't exist. Since the Big Bang, time has been flowing forward as the universe expands. Galaxies formed, stars were born and died, and planets like Earth eventually came into existence. Time is the silent thread that connects all these events. Without it, the universe would not have a history. But what about the future? Will time go on forever, or will it eventually come to an end? Some scientists believe the universe will keep expanding endlessly, and time will stretch on without limit. Others think the expansion might slow down, stop, or even reverse, leading to a big crunch where time as we know it could collapse back into nothingness. There are also theories of the universe fading into a cold, dark state called the heat death. In this scenario, entropy would reach its maximum. All stars would burn out, and all activity would stop. Time would still exist, but nothing new would ever happen, making the flow of time meaningless. These ideas remind us that time is not only personal or local, it is cosmic. Time shapes the birth of stars, the life of galaxies, and possibly even the ultimate fate of everything that exists. It is the stage on which the universe itself is written, from the first spark of creation to its final chapter, whatever that may be. So what is time? In one sense, it is simple. We use it to wake up in the morning, to plan our days, and to count the years of our lives. It is the ticking of a clock, the rise and fall of the sun, the beat of a heart. But when we look deeper, time is far more than that. It is a dimension bound together with space to form the structure of the universe. It bends with gravity, stretches with speed, and flows forward with the growth of entropy. Time began, as far as we know, with the Big Bang, and it may stretch far into the future, shaping the life and death of stars, galaxies, and perhaps the universe itself. For scientists, time is one of the most powerful keys to unlocking the secrets of reality. For philosophers, it remains one of the greatest mysteries. And yet, beyond all the science and theories, time has another meaning for us. It is the measure of our lives. Every second, every minute, every year is time we cannot get back. We cannot stop it, and we cannot reverse it. So maybe the real mystery is not just what time is, but how we choose to spend it. Because while the universe may hold billions of years, each of us only gets a limited share. And what we do with that time, that is what truly defines our story.